Let's go ahead and define the unit circle first. The unit circle is the circle with a radius of 1 centered at the origin in the xy plane. So that is, we could picture a circle here in the xy plane where the distance from the origin point outwards is a distance of 1. So here our radius is equal to 1 unit. Of course, it's important for us to denote a couple of points on this unit circle that we can find easily. The first one over here on the right is the point 1, 0. There's also a point over here, negative 1, 0. Both of these points lie on the x-axis. And then we have two other points. We have the point 0, negative 1, and 0, 1, that both lie on the y-axis. Next, let's show that the point 1/2 and root 3 over 2 lies on the unit circle. Since the unit circle is a circle with radius 1, it satisfies the following relationship. X squared plus y squared must be equal to 1. So to show that a point lies on the unit circle, we can take our x-coordinate and substitute it into our relationship, and our y-coordinate, substitute it into our relationship, and see if the sum of the squares is equal to the number 1. So we could take 1/2 square and root 3 over 2 and square that. 1/2 squared is 1 over 4, and root 3 over 2 squared is 3 over 4. And when we add these together, we do indeed get 1. So this point must lie on the unit circle. Next, let's look at a question where we're given the point negative 1 over root 2 comma y. If we know this point lies on the unit circle, we want to determine the y-coordinate of this particular point. Well, our point P must satisfy x squared plus y squared equals 1. Otherwise, it's not on the unit circle. So if we substitute our x-coordinate in, which is negative 1 over root 2, and we square it, we get 1/2. If we subtract 1/2 from both sides, we get y squared is equal to 1/2. And we can apply the square root of both sides here to get y must be equal to plus or minus 1 over the square root of 2. Now you might wonder, why are we getting two different possible y-coordinates? Well, if our x-coordinate is negative 1 over root 2, let's say maybe that is somewhere here on the x-axis. Notice that there are actually two different y-coordinates we could get because this is a circle. So we could end up with a point negative 1 over root 2, positive 1 over root 2, which is here on the unit circle, or we could end up with a point negative 1 over root 2, negative 1 over root 2, which is here on the unit circle. Often in calculus, it's much easier for us to talk about angle measures using radians rather than degrees. So I'm going to introduce the definition of a radian measure here. In our unit circle, we say that an angle theta is x radians, or x rad, if the length of the arc of our circle, subtended by the angle, happens to be x units long. So let's take a look at this picture. We would say that this angle here is x radians if this arc of our circle happens to be x units long. So I'm going to draw that arc in blue. And we're going to say that this is x units. If this blue arc is x units, we would say that our angle is x radians. Now what I'd like to do on this slide is I'd like to get some common measurements for degrees and radians. And what's going to allow us to do this is the fact that we're using the unit circle. So we could calculate the circumference, which is all the way around our unit circle, and this is given by the formula c equals 2 pi r. But our radius is 1, so the circumference is really equal to 2 pi. So this means the distance starting from here all the way around our circle is 2 pi. In other words, if we want an angle measurement all the way around our circle in radians, this must be equal to 2 pi. So we could say that 360 degrees is equivalent to 2 pi radians. The next measurement we might be interested in finding is 180 degrees. So using my red cursor here, I'll show you this is 180 degrees, which means we'd be interested in finding the distance from here all the way around to here. So if we can find this distance, we could figure out what 180 degrees is in radians. Well, this is just halfway around the full circle, so it must be 2 pi over 2. So 180 degrees is half of 360, which means it's going to be pi radians. And finally, the last one I want to think about is 90 degrees. So that is an angle measure here using the red cursor. So if I can find the distance from here up to here, that's going to be the radian measure for 90 degrees. Well, 90 degrees is just 1/4 of 360 degrees. So if we take our 2 pi radians and divide it by 4, we're going to get pi over 2 radians. What I'd like to do for the remainder of the lesson is show you how to convert between radians and degrees. This is going to be a particularly important skill for us to have, especially while we're first starting to use radians, because it might be more natural for us to think about degrees. So we need to have a way to easily convert back and forth. Let's begin by converting radians to degrees. If we have an angle measure in radians, we can convert back to degrees using the ratio 180 degrees over pi. Now where this ratio comes from is from the last slide where we looked at common radian measures. We found that 180 degrees can be thought of as pi radians. So if we take this equality and we divide both sides by pi, we get that the right-hand side is 1, and we get this ratio 180 degrees over pi radians. So it turns out that 180 degrees over pi radians is actually equivalent to the number 1, and this allows us to do our conversion. Let's convert the following two radian measures to degrees. The first one we have is pi over 4. Well, if we want to convert this from radians to degrees, we're going to multiply by the ratio 180 degrees over pi radians. Notice here that the two pi's are going to cancel out, and what we really are left to do is divide 180 degrees by 4. When we do that, we get 45 degrees. Next up is 3 pi over 2 radians. Once again, if we'd like to convert this from radians to degrees, we multiply by 180 degrees over pi radians. And our 2 pi's here are going to cancel. And we're left with 3 times 180 degrees over 2. Well, we know what 180 degrees over 2 is. That's going to be 90 degrees. So this is really like saying 3 times 90 degrees. 3 times 9 is 27. So altogether we have 270 degrees. Next, let's talk about how to convert from degrees to radians. In this case, we're just going to flip our ratio, and if we want to get our final answer in radians, we're going to multiply our degree value by pi over 180 degrees. This again comes from the simple equality that 180 degrees is equal to pi radians. So if we divide both sides by 180 degrees, we get that the value of 1 is equal to pi radians over 180 degrees. So multiplying by this ratio is really like multiplying by the number 1. Let's convert the following angle measures into radians. Starting with 60 degrees, what we want to do is we would like to multiply by the ratio pi radians over 180 degrees. What we can do next is notice that 6 is going to go into 18 3 times. So we're going to be left here with pi over 3 as our radian measure for 60 degrees. Next, let's look at 210 degrees. Once again, we'll multiply by the ratio pi radians over 180 degrees. Let's next remove the factors of 10 from 210 degrees and 180 degrees. From here, 21 and 18 both share factors of 3, so let's remove them as well. 21 divided by 3 is 7, and 18 divided by 3 is 6. So our final radian measure for 210 degrees is 7 pi over 6. All right, my little epsilons, stay positive.